Good morning, everyone. We are now on Quarter 3, Mathematics 8, Week 9 and 10. I am Teacher Ophelia from Ordineta City National High School. Our lesson for today is on applications of triangle congruence. After this lesson, we are going to state and apply the Isosceles triangle theorem and its converse. Isosceles triangle in real life. So we have pizza. We also have some chips. What kind of triangle is it? Yes, this is an isosceles triangle. Let's have a review on the parts of an isosceles triangle. So we have the vertex angle. We have two base angles which are congruent, and also we have two congruent legs. And we also have the base. An isosceles triangle theorem has two sides congruent. On our figure, we have side OL is congruent to side OI. And we also have two base angle, which is angle L and angle I, which is also congruent. Therefore, an isosceles triangle theorem, if the two sides of a triangle are congruent, then the angles opposite these sides are also congruent. If side OL is congruent to side OI, then angle I is also congruent to angle L. The angle opposite OL or side OL is angle I, and the angle opposite side OI is angle L. Another one, we have also converse of isosceles triangle theorem. If the two sides of a triangle are congruent, then the sides opposite these angles are congruent. If the measure of angle A is congruent to the measure of angle Y, then line MY is also congruent to side MA. Since the side opposite of angle A is side MY, and the side opposite angle Y is side MA. Okay. For activity number 2, we have equality for the win. Our direction, we are going to prove. Example, given triangle JOY or JOY is an equiangular triangle. When we say equiangular triangle, it has three equal angles. Now we are going to prove that triangle JOY is equilateral triangle. When we say equilateral triangle, three sides are equal. So, the first statement, number 1, we have triangle JOY is an equiangular triangle because it is given. Notice the base angle. Our base angle is angle O is congruent to angle Y. Our reason is the definition of an isosceles triangle. Number 3, we have side JY. Side JY is congruent to side JO. JY, the opposite angle is JO, and side JO, the opposite angle is angle Y. So we have the converse of an isosceles triangle theorem. Next, we have angle O is congruent to angle J. The reason, the definition of an isosceles triangle. We have number 5. Side JY is also congruent to side OY. The reason? This is the converse of Isosceles triangle theorem. Number 6, we have side JY is equal to side JO and congruent to side OY because of transitive property. Number 7, triangle JOY is an equilateral triangle because of the definition of equilateral triangle. Okay, activity number 3. Something is missing. Direction. You are going to illustrate what is asked by constructing them on the triangles presented. You are going to use a compass, ruler, and pencil. Given a line segment AB, and then you are going to construct or bisect line AB. First, you are going to place your compass point on A and stretch the compass more than half to point B. Okay? Number 2, you're going to, with length, swing a large arc that will go above and below. Okay? Number 3, without changing the span on the compass, place the compass point on B and swing the arc again. The two arcs need to be extended sufficiently so they will intersect in 2 locations. Number 4, you are using your straight edge, connect the 2 points of intersection with a line or segment to locate point C, which bisects the segment. Okay, note, on your activity sheet it is segment OD or line OD. But on our example, it is line AB. It will look like this. Okay, so you have AC is equal to CB. So side AC is congruent to side CB. Your C there is your midpoint of line AB. The M there is your perpendicular bisector of line AB. Now you're going to construct an angle bisector. What are you going to do? First, draw an angle on your paper. Place the pointer on the vertex. Draw an arc that intersects both sides. Move the pointer to the arc intersection with horizontal side. Make a second mark on the interior of the angle. Repeat on the other side. The last one, you are going to connect the arc intersections from the vertex. For your other reference on how to construct perpendicular and angle bisector, just visit the websites below. From Grade 8 Math Team, we have Mr. Manny C. Ancheta, Ma'am Reyna Corpus, Ma'am Paula Bianca P. Cruz, yours truly, Ma'am Rowena V. Palaming, and Mary Grace C. Talbo. Thank you and have a good day.